Welcome back to part 3 of the CRV Misfire project. So in this part, we're going to go through some more tests that students suggested and eventually get to the root cause and figure out what's going on with this misfire. So one of the really prominent suggestions from my students for testing this misfire was to do a leakage test. In our previous part 2, we saw that cylinder 3 was low on compression. And so that's a great next step to do to figure out where that compression is going. What I want to start this video with is some alternative test methods with the PicoScope, right? So I've got a PicoScope here. We're going to go through a handful of tests. So one is we're going to do a relative compression test by looking at starter current draw. And then I was excited to hear some students suggest that we should use the transducer and go in cylinder to see what's going on. So all these are great tests to do. Hopefully things that we can learn more about the vehicle without being very invasive or spending a lot of time. If you're like me, I'm not a big fan of leakage tests. They take a long time. They can be frustrating depending on the vehicle. And so anytime I can get away from that test, I'm into that. So we'll start with the relative compression test. We'll set that up and we'll see what we learn. So first test we're going to do is relative compression. So I'm going to use an amp clamp here for the PicoScope. I'm going to get that set up. I'm going to get my amp clamp and I'm going to put it around one of the battery cables. Ideally, I go to the one that goes to the starter, but really it could be on any of these cables. Whatever is carrying really a large amount of current to the starter will do. And so I'm going to look at that. I see this one goes to the fuse box. This one appears to go down toward the starter. So we'll go ahead and pick that one. I'm going to pay attention to my direction of flow, make sure I've got that set right. And this particular clamp on the PicoScopes, I've got an on switch. I've got to turn it on and I've got to zero it. So I'm going to go look at my screen. Here I can move the wheel and I can see it move back and forth. So I'm going to eyeball it, get it close to zero. We're going to be looking at large numbers, so having it exactly zeroed is not terribly important for us. The other thing that I'm going to do here is add a secondary ignition pickup. I'm going to put that on cylinder 1, ground the other lead here, and put it on channel B. That's going to help me understand where I'm at in my firing order and my sequence as I go through this test. I'm going to set up the test by going to charging and starting, relative compression, working on a gas engine or petrol engine. The PicoScope software is going to give me a setup guide. And so that's going to help me understand what we just did to get things set up. And so then I've got my preloaded waveform here. So it's showing me an example of what I'm going to see. And so I'm really looking for this spike that occurs. That's the starter motor beginning to rotate the engine. And then I see these individual pulses or peaks that represent compression strokes. I'm going to go ahead and clear that, hit running. I am also going to go ahead and add my B channel for a secondary ignition probe. I'm going to run that up to 10 kilovolts and leave that. My trigger is set, so it won't fill the screen until it sees that pulse. I'm also going to come over to my car and unplug my fuel injectors because I do need this to crank only. I'm going to leave my distributor plugged in so that I can get a pickup from my distributor for my ignition. We'll go ahead and crank it. All right, so here we got a waveform, and we'll go ahead and zoom in on one full event. And we'll place a ruler on my highest peak here to get an idea. So my B channel, my red channel here, is a secondary ignition synced on cylinder 1. And then each of these blue peaks represents the starter motor's amperage as it works harder to create compression. So every time I have a compression event, we have an increased demand from the starter, and so I get these peaks. And so if we go look up the firing order for the CRV, it is 1, 3, 4, 2. So this is my cylinder 1, cylinder 3, cylinder 4, cylinder 2. And so the interesting thing here is that we knew cylinder 3 had low compression. And so that shows me here it does not take the starter motor as much effort to build that 55 PSI versus the 100 so that we saw on cylinder 1. I've got a good peak on cylinder 1 and cylinder 4. We see that 3 is down. We see that 2 is also a bit lower as well. And so if we begin to think about the structure of the engine, 1 and 4 are companion cylinders, 2 and 3 are also companions. And if you think about both events that occur at TDC, whenever cylinder 1 is building compression, I've also got a little bit of resistance as I push exhaust gases out. And so I see similar events here. And so that kind of event might provide me some insight that the exhaust event for 3 might be impacting cylinder 2. So next we're going to go on to doing some in-cylinder testing. So I'm going to pull the spark plug out of cylinder 3. We'll put a spark tester on that plug wire. Again, I'm going to keep the distributor hooked up, and we're actually going to do a running compression test. And so I'm going to hook up all the fuel injectors with the exception of cylinder 3. So I've got my spark plug out. I've got my adapter here for the PicoScope. This has got threads for my spark plug as well as an O-ring. It is important when I use this tool that I double check the depth to ensure that I'm not going to go past where the spark plug would go normally. If that does appear to be the case, this kit has some aluminum spacers that thread on there that can help with that issue. So I'm going to set that just until it's hand tight. Put my transducer on. We're going to operate within range 1 for this particular test. And then I've got my BNC connector that goes on the end of my transducer. And I'm going to run this into channel 1 of my PicoScope box. I'll go ahead and turn off the amp clamp and get it out of the way. Before I do that test, I'm going to go ahead and save this waveform so that we can come back to it later. And so I'll make some notes. And there's lots of fields up top we can use. I'm just going to do this real quick, make some notes there, and we'll go on to our next test. Okay, so I'm going to zoom in on maybe 2.5 peaks here just so I can get them kind of centered with this zoom box mostly out of the way. And so we can see a handful of things going on. We're going to use some rulers to get a little bit better understanding of all the different events that occur. So I set my 2 rulers there, and then I go down to rulers. I want to use a rotation wrap. I want to partition that into 4 points. So there, I've got from 0 degrees to 720, and every 180 degrees, right? So this can help me understand where my piston is at within travel. So I know that I'm at TDC here. I go to bottom dead, top dead, bottom dead, top dead again. And so that pretty well helps me correlate events. And so there's a handful of things I want to look at to try to make some determinations of what's going on. One of those things is if I look at the base of where I start with my compression peak to where I hit here, if these pockets vary, that's a sign that some air has escaped. And so I know that corresponds with my low compression reading, and this confirms that. The next thing that happens here, this little flutter and peak right there, this is where my exhaust valve event should occur, and it's a big round pocket. Typically, we want to see pretty sharp changes as we go through valve events. So such as this, going from the exhaust valve event in stroke to intake is a really dramatic change, and we can see that. And so I'm leery of this big rounded pocket. So the next thing we'll do is we'll move our transducer over to cylinder 1. We'll check cylinder 1 and then we'll compare the two. All right, so we've got our capture here for cylinder number 1, and we'll get it set up in a similar fashion to what we did with cylinder 3. And as I go through this, we can look and see quite a difference in total compression from about 130 psi. We were closer to 78 or so, about 80 psi on cylinder 3. So that corresponds with what we already knew. And so then we'll do similar analysis here to what we had before. So rotational wrap is applied. I put my ruler here to look at the base of this compression tower. And so right off here, I can see I've got the same starting point and ending point to my expansion here. So because we don't have a spark plug in there firing, we don't have combustion. This is just really the piston compressing a volume of air and then relaxing it. And so we do expect, if we have a well-sealed combustion chamber, that we start and end with the same amount of air basically. And so that's a good sign. This tower is also symmetrical, which is a good sign. Then if we go on, there's quite a big difference in my exhaust events here. We talked about this pocket. This pocket has a much different shape to it. My pocket previously on cylinder 3 had a big kind of round slope to it. This one is a very defined exhaust valve event. I get to the bottom, right? I'm at bottom dead center. I begin to go upward, and right there, my exhaust valve opens. Go through my exhaust valve event, intake valve opens, and then I go back through the sequence. And so based on all this, pretty confident I've got multiple pieces of testing that have told me I probably have an exhaust valve issue. So next I was going to do a cylinder leakage test. I went ahead and decided I would just pull the valve cover first so that I could see the cam lobes and hopefully save myself a little bit of time getting TDC set as I went through that cylinder leakage test. So I got the valve cover pulled, got everything set up, and almost total leakage. Unfortunately, our shop compressor was off shortly before I did this, and so I only had about 50 psi to work with. So bear in mind that the numbers on this gauge are not terribly accurate, but it was enough to see that it was nearly 100% leakage. And so I thought I would show, basically the exhaust valve was too tight. It was coming out of the exhaust. And so I decided I would adjust the valve with the gauge still on, and so we could watch how that influenced leakage. And so I hope that this whole experiment was enjoyable for you. I think doing things like this and combining the PicoScope analysis with traditional methods is the best way for us to learn how to integrate those things. And I think the use of those tools is going to continue to evolve and really find its home. And so if you learned something, leave me a comment, let me know. If you're one of my students, um, hopefully this was educational for you. Thanks, everybody.